Hello and welcome to the first episode of Millionaire Math. In this channel we are going to learn about mathematics by playing the popular game Who Wants to Be Millionaire. Consider each episode as a formative test on a given topic. These tests will help you prepare for your school exams and hopefully you increase your performance in math over time. As this is the first episode, I'm going to assume that you know only the 4 basic operations with natural numbers, that is, with positive integers. You should be able to add, subtract, divide, and multiply numbers. Today's test is based on the topic of GCD, that is the greatest common factor, and LCM, the least common multiple, and is suited for grade 5 students or 12 years old. If you need more in-depth explanations to a given question, let me know in the comments below. So without further ado, let's play Millionaire Math. This is the first question. What is the remainder of 27 divided by 4? Is it 1, 2, 3 or 4? Give yourself some time to think about it. If you need to pause the video, pause it and give an answer to this question. I'll give you 5 seconds to think about it and then I'll tell you what the answer is. Okay, did you figure out C? C is the correct answer. The remainder is 3. Alright, let's go to the second one. If the dividend is A, the divisor is B, the quotient is Q, and the remainder is R, which of the following formulas is correct? Is it A divided by B equals Q plus R? Is it A equals B times R plus Q? Is it A equals B times Q plus R? Or is it B equals A times Q plus R? Think about it. Give yourself an example. You can use the example from the previous question. 27 divided by 4 equals 6 with a remainder of 3. I'll give you again 5 seconds to think about it and come up with a decision. Alright, the answer is C again. B times Q plus R. You can see in the previous example that if we divide 27 by 4, we get a quotient of 6 because 4 enters into 27 6 times and there is a remainder of 3, so 27 will be equal to 6 times 4 plus 3. So it's the divisor multiplied by the quotient plus the remainder. Alright, let's go to the next one. Again, we have the same notation. If the dividend is A, the divisor is B, the quotient is Q, and the remainder is R, which of the following is correct? R must be smaller than B, R must be greater than B, Q must be smaller than B, or Q must be greater than B. Think about it, 5 seconds, and I'll let you know the answer. The answer here is A. R must be smaller than B. You cannot have a remainder that is greater or equal than your divisor. For instance, if I divide 27 by 4 and I get a quotient of 5 and a remainder of 7, I haven't performed the division properly because I can see that 4 can enter into 27 not 5 but 6 times. If my remainder is bigger than my divisor, this means the divisor can enter an additional time into the dividend. So the correct answer is that the remainder has to be smaller than the divisor. Okay. Okay. If A is a multiple of B, then which of the following is correct? A can divide B without a remainder. A can be divided by B without a remainder. A cannot be equal to B, or A must be smaller than B. Think for some time and let me know what you think. Okay? Make your decision. The correct answer is B. A can be divided by B without a remainder because, for instance, again, it's useful to give ourselves examples. If A is a multiple of B, for example, 10 is a multiple of 5 because 10 is going to be equal to 2 times 5. So, is it true that 10 can divide 5 without a remainder? Obviously not, because 5 divided by 10 will give us a remainder. Is it true that 10 can be divided by 5 without a remainder? Yes, that's true, because 10 divided by 5 equals 2 with a remainder of 0. A cannot be equal to B, that's obviously not true, and A must be smaller than B. Again, if A is 10 and B is 5, A is bigger than B, okay? Let's go to the next question. Which of the following is not correct? Every natural number is a multiple of itself. Every natural number is a factor of itself. 0 is a multiple of every natural number, or 1 is a multiple of every natural number. Again, I'll give you 5 seconds. Think about it, read the questions, read the question and the answers again, and let me know what you think. Okay? Let's go over the answers one at a time. So, for example, is 5 a multiple of 5? Yes, 5 equals 5 times 1. Is 5 a factor of 5? Yes, 5 divided by 5 equals 1 with a remainder of 0. Is 0 a multiple of every natural number? Well, is 0 a multiple of 2, for instance? Well, 0 equals 2 times 0. So to be a multiple has to give a remainder of 0. If I divide 0 by 2, I get 0 with a remainder of 0, right? So the correct answer here is D. 1 is a multiple of every number. That's not correct, because 1 divided by 2 will give us a remainder. So 1 is not a multiple of 2. 1 can be said to be a factor of 2, but not a multiple of 2. On the other hand, 0 divided by 2 will give us 0 with a remainder of 0. So we can say that 0 is a multiple of 2. Okay? Let's go to the next one. If B is a factor of A, which of the following is correct? B cannot be equal to A, B must be greater than A, B can be divided by A without a remainder, or B can divide A without a remainder. 5 seconds. Okay, the correct answer is D again. B can divide A without a remainder. Again, if B is 5 and A is 10, so 5 is a factor of 10, this means that 5 can divide 10 without a remainder. 10 divided by 5 will be equal to 2 with a remainder of 0. The other ones are not correct. In C, B can be divided by A. That's not true because 5 cannot be divided by 10 without a remainder. Alright? Let's go to the next one. Question about prime numbers. Which of the following is correct? A prime number has only two factors, which are 1 and the number itself. 1 is a prime number, 2 is not a prime number. Prime numbers are finite. 5 seconds. The correct answer is A, right? A prime number by definition has only two factors. For example, 5 is a prime number. It can only be divided by 1 and by 5 without a remainder. Okay? 1 is not considered a prime number. 1 is an exception. It's neither prime nor composite. A composite number is a number which has more than two factors. For instance, 4 is a composite number. It can be divided by 1, by 4, and by 2. 1 is neither prime nor composite because it has only one factor. 1 can be divided only by 1 without a remainder, okay? So it's neither prime nor composite. 2 is a prime number, and prime numbers are infinite. Eratosthenes in ancient Greece, I think, proved that, okay? You can, if you're more interested in why prime numbers are infinite in amount, I refer you to Eratosthenes' proof of why that is the case. Okay, let's go to the next one. Which of the following is correct? 5,721 is even. 5,721 is divisible by 3 without a remainder. 5,721 is divisible by 5, or 5,721 is divisible by 9 without a remainder. Don't use a calculator. This is a problem which is intended to be solved without calculators. Think about it. 5 seconds and I'll give you the answer. Figure it out? The answer is B. Obviously it's not even, because to be even it has to end up with either a 0 or 2, a 4 or 6 or an 8. Okay, so the last digit is 1. This is an odd number. What was the criterion for divisibility by 3? A number is divisible by 3 when the sum of its digits adds up to a number that is divisible by 3. So if you add up the digits 5 plus 7 plus 2 plus 1, you get to 15. And because 15 is divisible by 3 without a remainder, this means that our number itself, 5,721, is also divisible by 3. Okay? Let me know if you need a proof of that. So if you need a proof of that, I'll do a separate video why that is the case. So 5,721 is not divisible by 5 because it doesn't end with 0 or a 5. And it's not divisible by 9 because the criterion was the sum of the digits has to add up to a number that is divisible by 9, sorry. Okay, so B is correct. (16 and 25 are prime numbers, even numbers, odd numbers, or coprime numbers. 5 seconds. Okay, the answer is D. These are coprime numbers, or mutually prime numbers. Again, they're not prime numbers by themselves because 16 is divisible by 4 in addition to 1 and 16. 25 is divisible by 5 in addition to 1 and 25. They're not even because 25 is obviously not even. They're not odd numbers because 16 is not odd, but they are coprime numbers. What does that mean? It means that they have only only one common factor. The only number that can divide both 16 and 25 without a remainder is 1. Okay, so when they're coprime, they have no common factors other than 1. Okay, all right. What is the greatest common factor, the GCF of 24 and 28? 5 seconds. Okay. The answer is C, 4. So both 24 and 28 can be divided by 4 without a remainder. 24 divided by 4 is 6, 28 divided by 4 is 7. And that is the greatest number that can divide both of them, of 24 and 28, without a remainder. Other numbers like 12 can divide 24, but it cannot divide 28 without a remainder. So the 12 will not be, for instance, a common factor. All right? Move to the next one. Only 4 questions left. Okay. What is the least common multiple, the LCM of 24 and 48? Is it 24, 48, 72, or 96? 5 seconds. The answer is B. It's 48. Again, remember that a multiple is a number that can be divided by something without a remainder. So 48 can be divided by itself by 48, so it's a multiple of itself. And at the same time, 48 can be divided by 24 without a remainder, because 48 divided by 24, it's 2 with a remainder of 0. So 48 is a multiple of both numbers, and that is the least common multiple. Okay, the smaller number that is a multiple of both. If 7630x is divisible by 3 without a remainder, but not by 2, which of the following digits can be substituted for x? Is it 1, is it 2, is it 3, or is it 5? Think about it. answer is 5. Let's test the options. So if the last digit is 1, it's going to be an odd number, so it's not divisible by 2. But if we sum up the digits, we get 7 plus 6 is 13, plus 3 is 16, plus 1 will give 17. 17 is not divisible by 3, and therefore, if we add 1 at the end, the number itself will not be divisible by 3. If we add 2 at the end instead of x, it will be an even number, so it will be divisible by 2, and we know that it should not be divisible by 2. If we add 3, the sum will become 6 plus 7 is 13, plus 3 16, plus 3 19. Again, not a number that you can divide by 3 without a remainder. And finally, if we add 5 instead of x, we get 7 plus 6 13, plus 3 16, plus 5 21. So 21 is divisible by 3, and therefore 7635 is also divisible by 3, but not by 2, because it's not an even number. Okay, move to the next one. Question of $500,000. Let's go. Okay. The local florist has 225 white and 175 red roses. What is the greatest number of identical bouquet that the florist can make by using all the flowers? Is it 25, 50, 75 or 175? 5 seconds. Okay. The answer is A, 25. Well, this problem is looking for the GCF, the greatest common factor, the greatest number that can divide both 225 and 175 without a remainder. So if we divide each of them by 25, we'll get quotients of 9 and 7. So we can make 25 identical bouquet, each containing 9 white and 7 red roses, right? And this is the greatest amount of equal bouquet we can make with all the flowers. Okay. Last questions for $1 million. John works 3 days, then takes 1 day off. Simon works 4 days, then takes 1 day off. If both have a day off on March 1st, when will they next have a day off together? Is it going to be March 19, March 20, March 21st, or March 22nd? 5 seconds. Answer is C, March 21st. So if John works 3 days and takes a day off, so this means that he has a day off every 4th day. If Simon works 4 days and then takes a day off, this means that Simon will take a day off every 5th day. And therefore, if one takes a day off every 4th day and the other takes a day off every 5th day, this means they both together will have a day off every 20th day, right? This is the least common multiple of 4 and 5. This is what the problem is asking us to find. So when we know that every 20th day they'll have a day off together, we have to add 20 days to March 1st. So the next day they'll have a day off together will be March 21st. If you want, you can make yourself a little calendar with the days of March, from March 1st to March 31st, and you can mark each time when either John or Simon has a day off. and you'll see that they both have a day off together on March 21st. Okay, that was today's video. I really thank the people who made the template for this presentation, because I found it for free online. I'll give you a link if you want to download the template, and if you have any questions, let me know in the comments below. Thank you so much for watching, and I'll see you in the next one. Bye for now.